Hello and welcome to this second tutorial that looks at binary fractions, or how we represent real numbers and show that the decimal part, the part after the point, the binary point, as a number. So if we look on the screen, now we treat this as a number without a decimal point, without a binary point in the middle. So we've got 1 is 2 to the power of 0. And we got that one is 2 to the power of 1. We have the next column 2 to the power of 2, next one 2 to the power of 3, next one 2 to the power of 4, next one 2 to the power of 5. Okay, so if we look at that, we can think to ourselves, right, if we uncover, well, cancel that, not sure what's happened there. We uncover the bound, let's have a look. So 2 to the power of 0, we've got a 1 in there, it's 1. 2 to the power of 1, but it's 0, so that's a 0. 2 to the power of 2, remember 2 times 2 is 4, there's nothing in there, so that'll be 0, but 2 to the power of 4, remember that's 2 times 2, which is 4, times 2, which is 8, times 2, which is 16, so that one will become a 16, and we put 1 in there, so if you haven't guessed already, of course, that's going to be 32. So we can represent that string of 6 binary digits by this series of numbers. So we can now do a little bit of arithmetic. So we have 32 plus 16, plus 4 plus 1. So I can use the magic of Excel, of course, on this. So I'll just add these up automatically. Here we are. And so the whole number, because this is just an integer, because we haven't got a decimal point yet, the whole number is 53. Let's have a think about this. Now, if I asked you to divide 53 by 2, you could do that in your head. You would say, hold on, that's 26.5. How do we represent that as a decimal, as a binary number rather? Let's have a little look. So, now, from the previous tutorial, see we've got the binary point there. So let's have a little look. So we're representing that. That's 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of, you've guessed it, 3, and 2 to the power of 4. So we can see which they are. Okay, so in there we've got a value, that's 16, and that should be 8, and that should be 0 because there's a 0 there, the digit isn't switched on. That's a 2, and that should be that as well. So now we can come over here and see, okay, so we've got 16 plus 8 plus 2. Okay, now use the power of Excel again, so equals sum, there we go. I could do this in my head, so of course. That's 26. So, okay, so but I have to deal with this pesky binary point. Just make that a dark one. There we go. Now, so we know it's 0.1, and from the previous tutorial we know 0.1 is a half. How is that represented in notation? Well, if we have no luck, it's represented as 2 to the minus 1. Yeah? Now previously we said, well, 2 to the minus 1, that's 0.5, so I'm just going to type 0.5 in there, and I'll add those up. So equals sum, here we go, power of Excel again, so that's 26.5. So, this is how we can represent 26.5. Here's the scientific notation, or the notation with the powers. Yep, and as we go up, know the pattern, so it's 2 to the 1, 2 to the 2, 2 to the 3, 2 to the 4, 2 to the 5, 2 to the 6, and so on. And as we come down, it would be 2 to the minus 1, 2 to the minus 2, 2 to the minus 3, and so on. Thank you very much for listening to this short tutorial.